Hello and welcome to Unit 2, Lecture 7, which is our review lecture for Unit 2, Introduction to Logic. Today we're just doing review problems, just going over various problems to see various things that will come up on these derivations. So I'm going to start with this one here. If neither not B nor not C, then not A. Show if A, then if B, then if not C. So whenever your show line's main operator is the arrow, I'm going to recommend you do it by conditional derivation. The way conditional derivation works, or to show a conditional, you assume the if part, use show line for the then part. We're going to show if B, then not C. Now we have a new show line. The new show line is another conditional. We do this by another conditional derivation. Assume B, new show line to show not C. At this point, we have a decision to make. We can either do this by indirect derivation or by direct derivation. Only do it by direct derivation if you can see how to do it by direct derivation. I can see how to do this by direct derivation, so I'm going to do it by direct derivation. But it's okay to do it by indirect derivation. If you didn't see how to do it, go ahead and do it by indirect derivation. So lines we can work with are 1, 3, and 5. So for line 1, we either need the if part or the negation of the then part. We don't have the if part, but we can get the negation of the then part from line 3. Line 3 says A is true. If A is true, it's not false. We need the double negation, though. Because do modus tollens on 1, we need the exact negation of the then part. So first we have to double negate line 3. So we double negate line 3, then we get the exact negation of the then part, of the if part of 1. 1 and 7, arrow out. We can drop off those double negatives. We just got an 8, not B or not C. So either not B or not C. To use an or statement, you need the negation on one of the two sides. We have B, so we get not B. And again, you have to double negate that. So we have the exact negation of what we need to, one of the two sides of the or statement. So I'll double negate 5, then I get not C. From 9 and 10, wedge out. That's what I was trying to show. So I've shown this by conditional derivation. So I've shown this by conditional derivation. Check the derivation, that's correct. All right, so this one is, the next one we're going to do is review of what to do for two-way arrow statements. For two-way arrow statements, you write direct derivation by the two-way arrow show line. But immediately under it, you want a show line to show the if then going one way. When we're done showing the if then going one way, we'll go back and show the if then going the other way. We'll do this by conditional derivation. Assume not N, show not M. Do that by direct derivations. It's not very hard. So we get if M, then N from line 1, two-way arrow out. Modus tollens gives us not M, 4 and 6, arrow out. So we've shown not M, so we've shown this. Now with the two-way arrow statements, you've got to do two conditional derivations. So we've shown the if then going one way. Now I've put in a show line to show the if then going the other way. Remember, you can't use anything that's in the boxes that you've already drawn. We'll show not if not M, then not N by another conditional derivation. So assume not M, show not N. And we'll show that by direct derivation. Now we'll get if N then M from line 1. It's the other direction of the double arrow out. Modus tollens on that will give us not N from 9 and 11. So we've shown not N, therefore we've shown that by conditional derivation. Now the last step is to take the two one-way arrows, put them together to get the two-way arrow. Not N if and only if not M from 3 and 8. Since the show is crossed off at 3 and 8, we can use those lines. Double arrow in. That's what we're trying to show at line 2. Okay? This one is review for what to do when you're trying to show an AND statement. So when we try to show an AND statement, my advice is to write direct derivation by the AND statement show line. but then put in a show line to show each of the two halves. First, we'll show P or Q. We'll do that by indirect derivation. So just like you use two conditional derivations to show the two-way arrow, you often use two indirect derivations to show an and statement. So we'll assume not P or Q, show splat. So negation of an or statement gives us a negation of each of the two halves for not wedge out. Neither P nor Q, then P is false and Q is false. Now we can use line 1. Line 1 says either P or Q and R, so we get Q and R by 1 and 6 wedge out. Then we get Q from line 8, ampersand out. Now we have our contradiction between 7 and 9. So we've shown that. We've shown that by indirect derivation, but we still have to put in a show line to show the other half of the or statement, show P or R. And we're going to do this by an indirect derivation, a lot like the indirect derivation we just did. We'll assume not P or R. Show a contradiction. So again, the negation of the or statement will give us each of the halves negated. So from line 12, we get not P and we get not R. Line 1 says either P or Q and R, so we have P, again we get Q and R from line 1 and line 14. That gives us R. So now we have a contradiction between 15 and 17. So now we've shown this and we've shown this. Now the last step is to put the two halves together with ampersand in. We've done two indirect derivations to show that each of the halves of the and statement. You need an and in statement to put the two halves together. So the lines I'm using are the crossed off show lines 3 and 11, ampersand in. So now I've shown this. Okay. I'm going to skip this one because it's quite long. I'm trying to keep these videos short, but it's just plugging away at what you have to work with. You assume K and L for conditional derivation, show not N. Assume N for indirect derivation, and you'll be able to get through that one. This one is review for something I call desperate measures, when you have to write in a show line to unstick yourself. Let's see how this actually goes. So you're trying to show conditional, so we'll do it by conditional derivation. Assume J, do a show line to show K. Show K however we want. I'll show it by indirect derivation. Assume not K. Do show line to show splat. Now, what do we do in this problem? The lines we have to work with, 1, 2, 4, and 6. There's nothing special to do with 2, 4, and 6. There's nothing special to do for a simple statement or its negation. So we're stuck in this problem until we can use line 1. If there's an arrow statement or statement you want to use, but you don't have what you need to use it, put in a show line. We could show if n then n, or we can show k or not j. We'd be able to unstick ourselves. So let's show if n then n. That's a conditional. I'll show it by conditional derivation. Assume m, do show line to show n. I'll show n by direct derivation. Notice I already have n up at line 2. So I'm going to use that rule you don't use very often, R, to repeat a line I already have. So I've shown n, so I've shown if m then n. So now I have what I need. Now that show's crossed off at line 8, have what I need to use line 1. So I get k or not j from 1 and 8, arrow out. I have not k up at 6, so I get not j. Either k or not j, but not k. So 6 and 12 wedge out gives me not j. Then I have a contradiction between the j at line 4 and line 13. That's not actually the shortest way of doing that problem, but that's the way I would recommend. Let's do one more problem where that comes up. We have to put in your own show line to show something. So let's do this one by indirect derivation. We're trying to show not f. Assume f. Show a contradiction. So f in line 1 gives us if C, then C, then G. 1 and 4, arrow out. Now I want to get the G from line 6, but I need if C, then C. I should be able to prove if C, then C. If there's something you want, you can always write in a show line to show it. If I show if C, then C, so I can do it by conditional derivation. Again, I'm just going to use line R, rule R, to get the C I already have. So I've shown if C, then C. That gives me the G I need from line 6. 6 and 7, arrow out. So line 2 is if G, then this whole thing. So I get this whole thing. That's 2 and 11, arrow out. Now again, I want to get the K and not K, so I could get splat, but I don't have if H, then if E, then H. So I'm going to put in a show line to show it. Show if H, then if E, then H. Do that by conditional derivation again. This is another conditional, so I'll do another conditional derivation. Assume E, show H. Do that by direct derivation. I already have H up at line 14, so I have H at 14R. So I've shown H, I've shown if E, then H, I've shown if H, then if E, then H. Then I get the K and not K. 12 and 13, arrow out. To get splat, I need to put these two things on their own lines. So I'll break up line 19. Oops. Now I have a spot between lines 20 and 21. So I've shown the splat, I've shown this. Okay, that's a pretty complicated one because there's 2 times where I needed something to unstick myself. So I put in a show line to show it. If there's something you need to unstick yourself, put in a show line to show it. That's called desperate measures. Here's an interesting problem you can do without using any premises. There's no premises. There's nothing here before the slash. So it's just a conclusion, but we can prove it. If something is a tautology that is true by logic alone, you can prove it without using any premises. So it's conditional. We'll do it by conditional derivation. Assume P. Show if P, then Q, then Q. That's another conditional, so I'll do another conditional derivation. Assume if P, then Q. Show Q. I can do that just from lines 2 and 4. I get Q. I've shown Q, so I've shown if P, then Q, then Q. So I've shown if P, then Q, then Q. All right? When I do these in person, I like to dance when I'm done with a problem. So now we're done with the unit. Let's dance at the end of the unit. Thanks for listening.